But Ramachandran has come across an even stranger condition, a remarkable ability of the brain that allows you to see even though you are totally blind. This rare condition is called blindsight. Ramachandran found Graham Young in Oxford, England. He is one of the world's few known blindsight patients. This paradoxical condition shows just how much our brains run our lives without our being aware of it.
Well, when I was 8, when I had the accident, it was a road accident that caused the brain damage, I literally used to walk into lampposts. I ran into, you know, these huge great pillars you get in stations. I ran into one of those one day.
The main visual centers in humans occupy nearly half the brain, in a large region towards the back of the head. Graham's vision was devastated by the accident. Today, he can see to the left, but is blind to everything on the right, in both eyes.
If you put an object in that part of the field and ask him what is it, he has no idea. He cannot perceive it consciously. And yet the remarkable thing is, if you move this object, he will tell you which direction it's moving, even though he cannot see the object.
Down, up.
You can see things over here.
Oh yes, I can see.
I'm going to move my hand across. You tell me when it appears, when it comes into view.
No.
Very precisely as it enters the seeing part of your field.
Yeah.
And if I just hold over here and you look there, you can't see anything?
No.
How about now?
You're moving it up and down.
But you're seeing it.
It's very easy for me to say to you, oh, I saw that move up, Colin. And as soon as I say that, you're going to say, ah, he can see. No, I can't.
A hypothesis is efficient.
Colin Blakemore is an Oxford scientist for whom Graham's mysterious abilities raise intriguing questions about consciousness.
I mean, blindsight is extraordinary when you see it. It's shocking. I think it's shocking because it brings home the fact that we can actually manage our brains without consciousness to some extent. And that leads to the question, well then...
Why not everything?
Why not everything? And why do we need consciousness for certain things? What is the extra gloss that consciousness gives, if anything, to our actions?
Right. I'm aware of individual functions of sight. Sometimes I'm aware of a motion, but that motion has no shape, no colour, no depth, no form, no contrast. Sometimes I can tell you what orientation it's at, but then we lose everything else.
So what you lack is the ability to put it all together and to recognise an object, a thing, something with meaning. Well, blindsight is this term introduced by Larry Weisskranz to describe the ability of people like Graham to detect things, but not to be aware of them. So very, very different from what we would normally call vision.
Right.
If there's one thing that this phenomenon of blindsight teaches us, it is that vision is not entirely seeing, that there can be a disconnection from the capacity to respond to visual information and the actual act of being visually aware of something. Those two things can be separated and probably are in our everyday lives. But the problem is that obviously we're not aware of the things that we're not aware of. We just don't know the extent to which they play a part.
It's almost as if the patient is using ESP. He can see and yet cannot see. So it's a paradox. It's almost like science fiction. How is this possible? Well, if you look at the anatomy, you can begin to explain this curious syndrome. It turns out from the eyeball to the higher centers in the brain where you interpret the visual image, there's not just one pathway, there are two separate pathways which subserve different aspects of vision. One of these pathways is the evolutionarily new pathway, the more sophisticated pathway if you like, that goes from the eyeball through the thalamus to the visual cortex of the brain. Now you need the visual cortex for consciously seeing something. The other pathway, which is older evolutionarily, and is more prominent in animals like rodents, lower mammals, birds, and reptiles, goes to the brain stem, the stalk on which the brain sits.
And from the brainstem gets relayed eventually to the higher centers in the brain.
Specifically, the older pathway going through the brainstem is concerned with reflexive behavior, orienting to something important in the visual field, making eye movements, directing your gaze, directing your head towards something important. In these patients, one of these pathways alone is damaged, the visual cortex is damaged. And because that's gone, the patient doesn't see anything consciously. But the other pathway is still intact.
And he can use that pathway to guess correctly the direction of movement of an object that he cannot see.
Graham's vision is similar to that of reptiles, who depend on unconscious blindsight for their survival.
A lizard, if it wants to catch a fly, for example, doesn't actually have to see a fly, it doesn't have to recognize a fly, it just has to be aware of something moving. So I suppose me and the lizard are distant cousins.
One of the goals of neuroscience is to understand which parts of the brain are dedicated to what function, how different mental capacities map onto different pathways and different neural circuits in the brain. And surely this fascinating syndrome is going to help us understand not only the nature of seeing, not only the division of labor between these different pathways, but the question of what is consciousness? What does it mean to be consciously aware of something? Why is one pathway alone conscious, whereas the other pathway behaves like a zombie that's trapped inside him, that's unconscious? The syndrome is so strange that when it was initially reported, people didn't believe it, and there are some people who still don't believe it. But in a sense, it's not that strange if you think about it, because in a sense, we experience blindsight all the time in our daily lives. For example, as I am driving this car and having this conversation, all my attention is on the conversation, on the person next to me. And in fact, I'm not conscious of what's going on around me. Even though I'm negotiating all this traffic, avoiding obstacles, avoiding that car on my right, avoiding the car on my left, that's all being done in parallel by another part of my brain, and it never emerges into conscious awareness unless something very strange happens, like a big truck passes by, I might notice it.
Blindsight enables us to steer our way successfully through the world, as if on autopilot.
How are we on the right side? Oops.
Without this zombie in our brains, we'd be swamped by visual information, unable to focus on what really matters. Unlike Graham, Peggy Palmer has normal vision.
She's not bad.
She should be able to copy this star easily.
I'll never get this star, I'm hopeless at this.
But something odd is happening. One whole side of the star is missing. Peggy has a condition called visual neglect. Although her eyesight is fine, half of her visual world no longer seems to matter. 10 years ago, Peggy suffered a stroke in the parietal lobes of her brain.
The parietal lobes are concerned mainly with creating a three-dimensional representation of the spatial layout of the world, allowing a person to walk around, to navigate, to avoid bumping into things. When the right parietal is damaged, the patient is unable to deal with the left side of the world.
This condition has fascinated neurologists for more than a century because it reveals not only how the brain shapes the way we perceive space in the present, it even determines the spatial look of our memories. This became apparent when Peggy was asked to draw a daisy from memory.
Right. A daisy it shall be.
For neuropsychologist Peter Halligan, Peggy's drawings reveal exactly what's gone wrong.
It's like a radar system, whereby the actual radar system on the left-hand side is no longer working well. If someone comes in on my left-hand side now, or I hear a sound, my eyes will immediately move to the left-hand side. That makes me, for evolutionary purposes, very aware of my environment. Because if I wasn't aware of those things, I'd have accidents. I'd get hurt, or I might get eaten by wild animals and whatever. Now, in Peggy's case, she will not attend to those things that we would normally be aware of.
Peggy thinks she's drawn her daisies right, until it's pointed out to her.
You've noticed that, have you?
Oh dear.
So what Peggy's drawn for us is several nice daisies with the left side missing. Same with this one and this one. And look at this one. This is a very good example.
I've done it on all of them.
Which means that she's not only neglecting events in the world, but when she conjures up a mental image, she's ignoring the left side of that mental image.
Well, I thought I was going all the way round, you see.
And this shows you that this is not simply a sensory problem, but a problem of consciousness.
I don't know. It's because I was so concentrating on that side. It takes everything away, you see. It's this attention, really. It's taken away. There must be two attentions somewhere in your body. That one side's taking the other one away. I can't make it out at all. Very odd.
Peggy's one-sided daisies graphically reveal how damage to the visual centers can warp our consciousness of the world, and how complex the human visual system actually is.
When I was a medical student, I was taught there's an area in the back of the brain called visual cortex, and that's where seeing takes place. But since then we have learned, in fact, there's not just one, there are 30 areas in the brain concerned just with seeing.
For Ramachandran, a walk through this Southern California mall shows exactly what these visual areas have evolved for.
And maybe these different areas are specialized for different aspects of vision. One area for seeing colors, another area for seeing movement, for form and shape, relative distance and depth. Now, despite this staggering complexity of all these different areas, there seems to be a simple overall pattern of organization. In fact, the visual input as it comes in seems to divide into two parallel streams of processing. There is one pathway which we call the how pathway, to which some of these areas belong, and that how pathway seems to be concerned mainly with navigation, with being able to walk around, avoid bumping into obstacles, avoiding uneven terrain, reaching out and grabbing something.
The how pathway leads from the main visual areas to the parietal lobes at the top of the brain, where Peggy suffered her stroke. The other pathway, the what pathway, leads from the main visual areas to the temporal lobes, located just behind our temples.
The what pathway is concerned with recognizing the object. What am I looking at? What does it mean for me? Is this an edible object? Is it a flower? Is it a person's face? What is it that I'm looking at, and what does it mean for me? That's what the what pathway is concerned with, and it's that pathway that seems to be damaged in David.